Start we
Started.
Assalamu alaikum everyone. This is Haris and today I'm going to present the role of wireless networks in the Internet of Things. So, firstly, what is Internet of Things? The Internet of Things is emerging platform and paradigm that enables the communication between the electronic devices and the sensors through the internet in order to facilitate our lives. So, like a system of interrelated internet connected objects that are able to collect and transfer data over a wireless network without human intervention. Like, for example, connected appliances and smart home security systems, wearable health monitors, and ultra high speed wireless internet, etc. IoT uses smart devices and internet to provide innovative solutions to various challenges and issues. So, next thing, the role of wireless communication. It's the most important. Wireless communication is like, what is the role of wireless network communication in internet of things, how the technologies changes, how the internet usage varies. So number one is wired communication, like ethernet cable have been replaced by wi-fi router. As the number of users increases, like then air acts as a medium in the wireless communication, so there is no conductor of physical wires between transmitter and receiver in the wireless communication. Next thing is radio propagation. It is basically the tendency of radio waves to travel from one point to another point or into the various parts of the atmosphere. Then propagation mechanisms, direct mode, line of sight is in which transmitter and receiver are in view of each other. There is no obstructions between the transmitter and receiver. Next thing is reflection. Reflection arises when the plane waves are incident upon a surface with dimensions that are very large as compared to the wavelength. Next thing, diffraction. Diffraction occurs according to the Huygens principle when there is an obstruction between the transmitter and receiver antennas and secondary waves are generated behind the obstructing body. Scattering. Scattering occurs when the plane waves are incident upon an object whose dimensions are on the order of wavelength or less and causes the energy to be redirected in many directions. Then multipath propagation. Multipath propagation plays a very important role in wireless communication because line of sight signal is not possible because of the obstructions. So in these cases, multipath propagation occurs. Then the particular receiver receives a signal from the various paths at different times and having different amplitude. This is basically the concept of multipath propagation. Next thing is different wireless technologies in IoT. Many different communication technologies are available today for using with IoT. Every technology has its own advantages along with their inherent limitations. So this combination of benefits and limitations of the technologies results in no single suitable technology for every situations like requirement and application. Number one is like Bluetooth, Zigbee, Wi-Fi, LTE, Li-Fi, ultra wideband. Now the benefits of wireless technologies. So we will watch in detail. Like number one, Bluetooth. Bluetooth has a lot of benefits. Like it has the ability to handle large amounts of data. It has the ability to create ad hoc connections, and Bluetooth is like universally standardized, and it's a free band. Then Zigbee. Zigbee is easy to set up, easy to, I think it has a low cost and low latency and low power consumption. So it is easy to set up, no expensive, and it has a multiple band support, supports different data rates, and supports low duty cycle operations. Then Wi-Fi has a high data rate supported, easier and cheaper to set up, and it's also universally standardized. Then LTE is basically the low cost on end device and base station. It basically operates on the license base and increases throughput and reduces interference from other devices. It also a narrow band operation which reduces power consumption. Then wideband. Ultra wideband has very low power consumption, very high data rate supported, and natural multiple access technologies and simple circuitry, and it has low cost. So next thing, the drawbacks of these technologies we discussed in Like Bluetooth, drawbacks are it has relatively low data rate and always up and relatively short range, high power consumption. And with Zigbee, next thing is Zigbee, no security. Zigbee is not secure as compared to the Bluetooth and short range, low data rates, and suffers from compatibility issues with devices from different manufacturers. Next, Wi-Fi. Wi-Fi has a lot of also has a drawbacks in which includes high power consumption, vulnerable to attacks, and becomes slower with increasing the number of user connections. Signals blocked by obstacles also in this case. LTE has cellular data plans, may increase user charges, and then ultra wideband has a short range, and antennas are hard to design and implement. So now, Sama, you should continue the rest of the slides. Thank you. Yeah, man.
Was it? Okay, so from now onwards, I will explain you the challenges of IoT in wireless. The challenges are interoperability or standard issues. Basically, interoperability is the feasibility to exchange the information among different IoT devices and systems. Exchange of information does not rely on deployed software and hardware. Basically, interoperability issue arises due to heterogeneous nature of different technology. Basically, the four interoperability levels are technical, semantic, syntactic, and organizational. Then we have ethics, law, and regulatory rights. Uh, Basically, the main issue for IoT developers are ethics, law, and regulatory rights. There are certain rules and regulations to maintain. There are some standards and some moral values to prevent the people from violating them. Then comes the scalability, availability, and reliability. A system is basically scalable if it is possible to add new services, equipments, and devices without degrading the performance. The main issues of IoT is basically to support a large number of devices with different memory, different processing, different storage, and different bandwidth. So another important issue is the availability. Scalability and availability both should be basically deployed together in the layered framework of an IoT. A large example of scalability is basically cloud-based IoT systems, which provide sufficient support to scale the IoT network by adding to new devices, storage. Basically, it's a cloud, so we can add a lot number of devices, a lot number of storage, and processing power can be used as per our requirements. Then another important issue is availability of resources to the authentic objects regardless of their location and time of requirement. There are several small IoT networks which are literally attached to the global IoT platforms to utilize their resources and services. Therefore, availability is the important concern. Then we have quality of service. The quality of service is important for IoT. It can be defined as measure to evaluate the quality, efficiency, and performance of IoT devices, systems, or the overall architecture of the IoT device. Then we have, okay, there are different types of IoT networks in wireless. Number one is cellular. Basically, cellular, we will discuss them one by one. Either cellular, local, and personal area networks, low power wide area networks, and we have mesh networks. So we'll be discussing them one by one. Cellular networks are the same mobile networks as smartphones to allow IoT devices to communicate. They are reliable and secure methods of communications. The main protocols we use are LTE and no narrow bandwidth IoT. LTE-M is basically a great option for IoT connectivity if you're willing to pay the price, and if you have, if you're in the your case is low power. Narrowband IoT is somewhat less costly than LTE-M and use less battery power, but there's not enough coverage everywhere to reliably deploy an NV IoT. Then we have local and personal area networks. Networks that cover fairly short distances are called personal area networks and local area networks. uh, Fairly cost effective, but sometimes they have unreliable. Technologies basically used are Wi-Fi and Bluetooth, and protocols are Bluetooth low energy. Basically, Wi-Fi can be used for applications that run in a local environment. In a distributed environment, if there are multiple access points integrated into a larger network. One downside to that is it works only if the signal is strong and you are close to that access point. A protocol is basically Bluetooth low energy. It's the more energy efficient wireless protocol, but it is not receiving the data constantly. A single battery running BLE could last up to 5 years. However, compared to Wi-Fi, it is slower to transmit and is more limited to amount data it is capable of sending. Next, we have low power wide area networks. Send small packets of information infrequently and for long distances. Long range than Wi-Fi and Bluetooth, and the protocols which use is long range wide area network. Long range wide area networks runs on the long range communication network. The advantage of long range wide area network for every devices are its low power requirements for long battery and relatively low cost. A single base station or gateway running on a long-range network is capable of providing services to a very large area. A few kilometers is dense urban areas up to 15 to 30 kilometers in rural areas. Then we have mesh networks. Mesh networks are best described by their connectivity configuration, how the components communicate with each other. Basically, mesh network is the mesh of different systems togetherly connected. All the sensor nodes cooperate to distribute data among each other to reach gateway. The main example is ZigBee, short range and requires extra sensors to get to the long range, and it is fairly robust. Then we have the problems we are facing in the IoT devices are fading. Fading, we have two types of fading: small scale and large scale fading. Small scale fading refers to the rapid changes of the amplitude and phase of a radio signal over a short period of time, on the order of seconds or only for the short distance. Large scale fading is basically a result of signal attenuation due to signal propagation over large distances and diffraction around large objects in the propagation path, relative path.